Hello everyone. So let's now solve practice assignment week 2 question number 1. So the question says consider the following system of equations and choose the correct options. So we have given three system of linear equation, system 1, system 2 and system 3, and we have to identify whether they have unique solution, infinitely many solution or no solution. So let's check them one by one. So system 1. So for system 1 we have minus x plus 2y minus 2z is equal to 2x plus z equal to minus 1 and x minus 3y plus z is equal to 3. So with respect to this equation, the matrix representation would be minus 1, 2, minus 2, 2, 0, 1, 1, minus 3, 1. So this will be our A matrix. Matrix X will be X, Y, Z and matrix B would be 2, minus 1, 3. So the augmented matrix, that is A, B, would be minus 1, 2, minus 2, 2, 0, 1, 1, minus 3, 1. So this was our matrix A, and now we will put the matrix B here. So 2, minus 1, 3. So this is our augmented matrix. Now we will use our row operation to row reduce this matrix in REF or RRDF form. So let's first do operation on second row, that is R2 plus 2 times R1, and on third row it is R3 plus R1. So first row will remain as it is, and on second row it would be 0, 4, minus 3, 3, 0, minus 1, minus 1, 5. Now let's again do a row operation, that is R3 plus 1 by 4 R2. This we are doing on third row, and we will get minus 1, 2, minus 2, 2, 0, 4, minus 3, 3, 0, 0, minus 7 by 4, 23 by 4. Now from back substitution, we will get from here, we will get minus 7 by 4 z is equal to 23 by 4, which gives us z is equal to minus 23 by 7. And from this, we will get 4y minus 3z is equal to 3. So 4y is equal to 3 minus 3 times 23 by 7. So we get y is equal to minus 48 by 28, that is minus 12 by 7. Now from first, we will get minus x plus 2y minus 2z is equal to 2. We have already found out y and z, so it would be minus x minus 24 by 7 plus 46 by 7 is equal to 2. We got x is equal to 2 plus 24 by 7 minus 46 by 7, and that would be equal to 8 by 7. So the system will have unique solution as we got only one intersection point for these three equations. So option 1 would be correct answer. That is, the system 1 has unique solution. Now similarly, let's check for system 2. So system 2. So the equation for system 2 we have minus 2x plus y plus z is equal to 0, 3 by 2x plus 2y minus z equal to minus 2, 3x plus 4y minus 2z is equal to 5. So yeah, so this was our equation for system 2. Now as we done before, we'll try to find the matrix representation of the system of linear equation. So our matrix A would be minus 2, 1, 1, A by 2, 2, minus 1, 3, 4, minus 2. Matrix X would be X, Y, Z, and matrix B would be 0, minus 2, 5. Now the augmented matrix, this would be minus 2, 1, 1, 3 by 2, 2, minus 1, 3, 4, minus 2, and our B matrix, that is 0, minus 2, 5. Now we will try to reduce this matrix. So we will do a row operation on second row, that is R2 plus 3 by 4 R1. So we will get first row will remain as it is. Second row, it would be 0, 11 by 4, minus 1 by 4, minus 2. And the third row will remain as it is. Now let's do a row operation on third row. That is R3 plus 3 by 2 R1. So the first row will remain as it is. Second row will also remain as it is. And for third, this would be 0, 11 by 2, minus 1 by 2, and 5. Now let's do one more operation. That is R3 minus 2R2 on this matrix. Then we will get first row will remain as it is. Second row would be as it is. And the third row, it would be 0, but here it would be 9. Now we have got 1 0 row on the left hand side of this line, while a non-zero number on the RHS side. So this means here this corresponds to that 0x plus 0y plus 0z is equal to 9. So basically 0 equal to 9, and that is not possible. And hence the system will not have any solution. So whenever we have any non-zero row whose corresponding entry in the B matrix for augmented matrix is non-zero, then the system will have no solution. So the system 2 will have no solution. That is option 3, while option 2 is wrong. Let's check for system 3. System 3. So for system 3, our equations are like this. x plus 3z is equal to negative 5 minus 2 by 5x minus 1 by 5y minus 2z is equal to 3. 2x plus y plus 10z is equal to negative 15. Again, we will find the matrix A, X, and B. So matrix A would be 1, 0, 3, as the coefficient for y in the first linear equation is 0, minus 2 by 5, minus 1 by 5, minus 2, 2, 1, and 10. Matrix X would be same X, Y, Z, and matrix B would be minus 5, 3, minus 15. Now, augmented matrix would be 1, 0, 3, minus 2 by 5, minus 1 by 5, minus 2, 2, 1, 10, and here minus 5, 3, minus 15. Okay, now, so again we will be doing some row operations to row reduce this matrix to check whether the solution exists. If it exists, then what type of solutions they are. If it is not, then no solution. Let's do one row operation on second row. It is R2 minus 2 by 5 R1. So if we do that, 1, 0, 3, the first row will remain as it is. On second row, here it would be 0 and minus 1 by 5 minus 4 by 5, it would be 1, and the third row will remain as it is. Now let's do the operation on third row. So R3 minus 2R1. So we will get first row will remain as it is. Second row will also remain as it is. And the third row, it would be 0, 1, 4, minus 5. Now let's again do the operation on third row. This R3 minus 5 times R2. So we'll get 1, 0, 3, minus 5, 0, minus 1 by 5, minus 4 by 5, 1, and 0, 0, 0, and here also 0. So we got a whole row 0 in the augmented matrix. So also we can check that there's one column which doesn't have pivot entry. That is, if we let's say further row reduce this matrix by doing an operation on second row, that is minus 5 times R2, then we will get 1, 0, 3, minus 5, 0, 1, 4, minus 5, 0, 0, 0, 0. So we have this matrix now, and at first column have pivot, the second column have pivot. Pivot means the leading non-zero entry, in our case it is 1. So the first leading non-zero entry in a row in the row reduction form is called the pivot element. That is this one here, that is present in first column, this one that is present in second column. But in third column, as it doesn't have any pivot entry, so our third variable, that is z, is an independent variable. And in the case when we have independent variable, the system will have infinitely many solutions. And also we got 1, 0 here. So as third column does not have pivot element, Z is independent variable, and hence system will have infinitely many solutions. So that means option is wrong, which says system 3 has no solution. So in conclusion, uh, for checking any system of linear equation, whether it has unique solution, no solution, or infinitely many solution, we first try to form the augmented matrix and then try to reduce the matrix using our elementary row operation. And if we got a unique intersection point, then the system will have a unique solution. If at any point of time in the row reduction we give a condition like this, where in the side of A matrix it is a zero row, while in the side of B matrix in the same row it is a non-zero entry, then the system will have no solution. While if we get a independent variable, then in that case it will have a infinitely many solution. Thank you.